let's talk about understanding what is an inscribed and what is a circumscribed triangle. Along with that, in this tutorial, we will also cover how to construct each one of those kind of triangles, okay? So in geometry, we define that a shape is called an inscribed shape if it is inside another shape, all right? So take a look at this diagram, the diagram number 1. You see that there is a triangle in blue, right? And it is completely inside this circle, such that all 3 vertices of this triangle are touching the circumference, right? So such a shape, this triangle will be called inscribed triangle because it is inside a circle, okay? So given that, when you take a look at the shape number 2, you will see that this triangle, the one that has blue lines, is outside this circle, right? Such that 2 out of 3 sides are touching this circle. So this is another kind of example of a circumscribed triangle. And the reason we are calling this as circumscribed because it is outside this circle, right? And likewise, when you take a look at the shape number 3, this triangle, the one which is in blue line, is also outside the circle. But in this case, all 3 sides of this triangle are touching the circumference at 3 points. Okay, so this is another good example of a circumscribed triangle. Alright, so having understood the difference between a circumscribed and inscribed triangle, now actually go and construct one, okay? So in this case, we are going to construct a circumscribed triangle. So what we have with us is a triangle ABC, and what we want to construct is a circle such that it fits inside this triangle, okay? And the method is very simple. What we want to do is that we want to obtain a perpendicular bisector of each one of the sides of this triangle, and wherever they meet, all 3 of them, wherever they meet and intersect at one common point, that will be labeled as the center of this triangle, okay? And from that center, then we will create a circle. So first, let's obtain a perpendicular bisector of the line segment AB, and for that I need a compass. What I'm going to do is that we know the method of creating a perpendicular bisector. You open up the compass a little bit more than the half of this line segment AB, right? And then obtain an arc above and below that line segment, okay? So just like that, we are creating here 2 arcs. One is above and one will be below this line segment. Okay, so that is one set of arcs. And likewise, I'll have another arc from the other end without changing the radius of this compass. So now I have 2 arcs that are intersecting with each other. Now, when I join these intersecting points, that's when I obtain a perpendicular bisector. Okay, so let's do that. So the blue line that you see here, it is a perpendicular bisector of line segment AB. And just like that, we will obtain a perpendicular bisector for the line segment AC next. So once again, we bring our compass back, we position it at the vertex A and then open the compass a little bit more than the half of this line segment. Okay, so once you're done with that, let's create 2 arcs and then position your compass at vertex C and repeat that entire process all over again. So we notice that we have obtained one intersection point here on the left of this line segment AC and one intersection point right here. And as I join these 2 intersecting points, I will obtain one more perpendicular bisector, and this time it is for the line segment AC, alright. Now we need to make sure that the first perpendicular bisector that we had, it is stretched long enough so that these 2 perpendicular bisectors, they intersect with each other. And just like that, we are going to obtain a perpendicular bisector on the line segment BC, okay. So we notice that these 3 perpendicular bisectors, they all are intersecting at one common point where you see my black cursor, correct? And this is the center of this triangle. This is how you actually obtain a center of this specific triangle, okay? By connecting 3 perpendicular bisectors, okay? And this is exactly going to be the center of our circle. So what we do is that we position our compass at that center point and open the compass wide enough so that you are actually obtaining the shortest possible distance from this center to any one of those sides, okay? So this is my shortest possible distance. That is going to be the radius of this circle, and then we simply create a circle. So this circle that you just obtained, this is a circle that touches 2 line segments, line segment AC and line segment BC. And this is your circumscribed triangle, okay? So what we have accomplished so far is that we already have a triangle and a center of this triangle. So using these two facts, we can very easily obtain an inscribed triangle. What we do is that we position our compass at the center of this triangle and open up to one of the vertices, which will be at the farthest possible distance from this center. And notice that the vertex C is at the farthest possible distance. So using this radius from the center to the farthest possible vertex, we simply draw a circle, and this is your inscribed triangle now. A circle in blue and a triangle in red gives you an inscribed triangle. A circle in black and a triangle in red gives you a circumscribed triangle. Okay, so this is the method and way to obtain your circumscribed and inscribed triangles. Okay, and this was the objective of this tutorial. With that, we will take a pause here, and that concludes our discussion on the construction of variety of triangles inside or outside a circle.